Good evening, everyone. Yes, thank you. All right, I promise I will try to keep it interesting because normally I don't attend any panel. I've never attended a panel session because I don't like panel sessions. But if my company tells me I have to do a panel session, then I have to do a panel session. So I'll try and keep it fun, light. I've been working on IoT for a long time now, specifically around security testing. And it is messy, because the attack surface specifically for IoT is huge. I mean, it's not like just one mobile application that you have to assess. It is the hardware, it is the firmware, it is the radio communication, it is the cloud, it is the mobile, it is the web, everything combined. So obviously we get a lot of customers who want us to test their products, and I kept on wondering how is it that product manufacturers manage their security, given that they're not the end manufacturers. It is all supply chain, specifically for IoT. So when I say IoT, I say it in a very loose term. I'm talking about anything which is connected. So for me, IoT is connected cars, industrial devices, home automation, healthcare, and anything basically which is connected. So my company told me to do a panel, and I thought let's get all the best gentlemen from different domains in IoT, specifically manufacturers, and grill them about how do they manage supply chain issues. All right, so let's start. What we'll do is we'll keep it like a standard format, question, answers. I'll try not to embarrass them, but feel free to take notes and grill them in the end. I can't do it, right? Because they're our guests. All right. So what we'll do is we'll start with 1 minute introduction for everyone, and then their take on IoT supply chain security issues. So let's start with Sudarshan.
Hi, everyone. I know when you have a speaker like that, I don't know what to say, right? So my name is Sudarshan Rajgopal. I am representing Shell here. I work for Shell as a CC manager, which is compliance manager competency center manager for security and compliance. That's the domain where I work with. In the industry where we are, and of course, as you see from a larger perspective, just to give like a quick thought on IoT and in supply chain. So I think right now, like everything is getting connected, the legacy to the next gen, and with a single switch, you can do a lot of things. I think the security plays a paramount role, and that's where I'm more keen to learn from you and the fellow panelists about what it is, and to probably impart what I have learned from there. That's the idea why I'm here. Thank you.
Thank you. My name is Suva Bratasena. I am the CISO for NXP Semiconductors. It's a specialist security-focused silicon manufacturer and solutions company that you may not have heard of. But I bet you pretty much every mobile device you use, pretty much all the iconic cars that you know of, and pretty much all the carriers that carry your signals. I mean, we are there. It's a exciting business, especially this time of our technology evolution and everything that's happening around us. So to me, IoT supply chain security is very, very close to heart, both from our core business as well as in my role as the CISO. And I think we are here talking about it because in spite of all our experience with supply chain and supply chain security and supply chain integrity, years of experience, we have still managed to get IoT supply chain wrong again, right? And that is why it is an issue. And at its core, it boils down to this, that when procurement or the procuring organizations buy anything to do with IoT, their lights twinkle with cheap and generic. 20-cent parts, $1 parts, $2 parts. Whereas the reality is most IoT components now are connected. They have fairly decent amount of compute. They have storage, and they often have an incomplete network stack built in. Right? So it's a recipe for disaster. And the disaster is upon us today.
Hey, good afternoon. I almost feel like I'm sitting. Yeah. So I almost feel like I'm sitting for an exam with Asim as my teacher, hovering in the background. Teacher, they keep walking around, and while you're scrambling to write, I almost get that feeling. So my name is Anant Iyer. I am from Johnson Controls, and I'm part of the global product security team. I handle the assurance testing function within Johnson Controls. So for me, IoT supply chain is a very critical aspect, because when we get a device to be tested, the components actually come in from multiple sources. There is no one single source from where the product is delivered. So either the board is assembled somewhere, it is integrated by somebody, and then it kind of comes to us for testing. So when we actually go ahead and do the testing, we find there are too many issues. While we look at it from a individual component perspective, probably there wouldn't be much of a problem. But when we look at an integration of multiple points, it leads to a lot of issues. And that in turn causes a lot of ripples across. So I think my aim is to kind of look at, we have panelists from the semiconductor industry, from the medical side, from the energy side. So try to understand how do we kind of, as an industry, kind of look at mitigating it or trying to get a handle on some of these issues. Thank you.
Hey everyone, I'm Kedar, Senior Director of Engineering for Espressif Systems. I'm sure many of you might have hacked on the ESP32 or ESP8266. Those are the kind of devices that we make. For me, the IoT in supply chain is a very critical component that we need to look at, because as more devices get connected around us, we see precedents wearing smartwatches, and their heartbeats are being sent out to some cloud server somewhere. So even before the meeting ends, which direction the meeting is going, right? And there's a lot of attention being given on the cloud side security of things and the penetration testing of things. But what IoT security in the supply chain means is that how are the devices assembled, and what are the parts of the supply chain that are completely untrusted, and how can we as an industry ensure that there are technological solutions that ensure that it is just impossible for people to fake these or introduce malwares or exploits into these. And the other part of it that I also deeply care about is how we can do this because everything comes at a price, but how we can do this at as much level of affordability that even a smart light bulb that you have in your house that you probably bought for $400-500 has the same level of security assurance as some of the other more sensitive components. Thank you.
All right, great. Thank you. So, my name is Sachin Jain, and I'm having more than 21 years of experience in the industry, including consumer electronics, automobile, medical devices. I'm with Stryker for more than 11 years, and probably 9+ years into the security. And some of my area of interest is like side-channel attacks, EM fault injections, and laser attacks, and binary reverse engineering. So basically, those are something which keeps me live, and I'm more than happy to be part of this panel and here to contribute whatever best I can and learn from everybody here. And of course, like what I get a feeling is like in the movie Sholay, like kitne aadmi the, and
I was going to say that.
That's kind of feeling I am getting. Like that's how Asim is looking like at us right now. But yeah, I'm really thanks to Aseem and the Nalcon team, and more than happy to answer any of your questions here. Thanks.
All right. Thank you and welcome all of you. All right. Let's take a step back and let's first answer the question that is supply chain actually a real threat, or are they like whims and fancies of people like Pareto or companies like Pareto to sell their services and products? Anant, let's start with you.
So, personally, I feel it is a very, very valid issue, and it's not like it's going to happen. It's already happening. Now, there have been a lot of coverage. A couple of years back, we had the Target attacks. Now, if you look at from where it actually originated, it was from an HVAC provider. So, it is not about whether it is going to happen. We are already there. Year on year, we are looking at somewhere around, as per last year's statistics, we are looking at around 217% increase in on attacks on the IoT devices. So it's high time we start taking this seriously. I think we are already there. We need to have, as an industry, look at clubbing our thought processes and putting something together. I think that's where we are already.
So, you're right, it's already a threat. And it's a real threat for a number of reasons. Let me list two. One is just the sheer proliferation of IoT devices. I mean, we already have 1 billion mobile phones, computers, and these are all $500 to $1,000 parts. But industrial IoT are all, as I said, for $25, $30, $35 parts. So you can imagine the pace at which industrial IoT is proliferating. The second reason why it is a problem is because when you look at industrial IoT, there are typically two things they can do. Many of them can do. That when you talk about consumer IoT like phones and the consumer connected devices like phones and stuff, they don't. One is many of those can sense. Right? They have sensors built in. There's a sensing functionality. So if you can compromise a sensing device, set of sensing devices, you can get access to pretty much real-time feed of sensing data. But much worse is that many industrial IoT devices are set up to be actuating devices. It can, as a part of its functionality, actuate something. Start your car engine remotely, switch it off. Turn a machine on remotely, switch it off, make industrial robots go a certain way, do a certain thing. And again, when you're talking about compromise, how much would you really pay to make this thing go away? Right? So, and that limit is not a function of the value of that $40 asset, right? It's a function of your how much business loss you can really bear. And that's going to be a lot of losses. And that day, unfortunately, is almost upon us. Right? And that's why it's a problem.
Actually, I just read a few days back, a McKinsey report. We are looking at, by 2030, economy worth ranging from $5.5 trillion to $10.5 trillion that is going to be enabled by IoT. So you can just imagine the sheer scale for anyone to kind of play around with. Or that is the, what you can say, the spectrum of what is going to be enabled by IoT.
It almost takes me back to the days of Windows NT. I don't know how many of you remember this, but NT stood for network technology, right? Those were the operating systems where networking just came into operating systems, right? That was the time. Today we are saying IoT because we are saying internet is just getting into things. But I think after a few years, it will just be things. We don't even know which of them are network connected, which of them are not. So it's, to your point, the scale of devices that are connected to the internet becomes significantly larger. And as Suo mentioned, it directly has an impact because it affects the physical world. It's not just, oh, my hard disk is corrupted, but it affects the physical world. It can start fires, it can lock you out of your house and things like that. So it becomes all the more important for us to look at it with sufficient attention and guidelines.
Yep, I completely agree with the panel here, and I believe medical is no more different than what these guys are looking at right now. I mean, of course, COVID has taught us some very highly accelerated change in this patient health, patient safety, and the parameters or the PIA information or the data which has been shared over the internet. So, I was reading probably somewhere they're talking it's $1 trillion by 2025 or something. So it's pretty much real. This poses some real, threats and the risk which everybody needs to be aware and think about it.
So, if this is real, then who are these adversaries? And the basic idea is, what is it that they gain out of it? So, Sudarshan, you want to take it?
I think that's an interesting question when you talk about who are the adversaries. And I can relate this with something like a guerrilla warfare. You do not know who's the one, and you probably can say. So there are states which are sponsoring this. There are groups which are sponsoring this. There are people who want to make money out of it are doing it. There are different kind of people. Now, I mean, if I may quote the examples of, say, you had Colonial Pipe, which went through something like this. You had SolarWinds, which went through something like this. And we might talk about it somewhere in the course of the discussion about these cases. But if you look at it, I think for me, it would be zero trust. For me, it would be like you don't trust no one. Everyone can do it. So you need to have security around it. But also, word of caution, and I think from a security perspective, we also see that we try to build a Fort Knox everywhere. This kind of security we want to have it, that because of the fear of unknown, we want to have everything secure to the hill, to the T. That creates a lot of overhead, a lot of time, a lot of problems. So I think need to know or need to secure kind of a thing needs to be there, but that the balance is left to an individual, and that's the way I would look at it.
Anyone else wants to give their take?
So, I mean, what I would imagine is from a perpetuator perspective, they are no different from what we see today in the traditional IT world. Because end of the day, that's where the money flow is. That's where I can cause maximum disruption. That's where I can cripple a nation's economy. So with infrastructure or an ecosystem that can offer me so many different possibilities, automatically there are too many groups, too many individuals, too many entities that can gain benefit from disrupting that entire ecosystem. So the perpetuators are going to remain the same. The intent will be the same, and that has been the same, will be the same, and probably in the future they will remain the same. So I think the bigger question is how do we protect ourselves from it? How do we protect the larger audience, the consumers to whom we all interact with? How do we protect them and cause minimal disruption? I think that's the key point over here.
Yeah. After getting into IoT, one of the things that I'm very careful about is when I have to buy something from Amazon, because that is the easiest attack vector. All you need to do is just put the backdoor in the device, sell it in the e-marketplace. All right. So next question, I'm going to combine two questions here. A, what is missing in the current processes within the organizations, and how does an effective strategy to combat supply chain issues looks like? Suva, you want to take that?
Yeah. So there are a couple of very basic things which are missing from the perspective that Asim talked about, from my point of view. Number one is applying the discipline that we have applied to secure development life cycles all along, at least in the last 10 years. We need to apply it in IoT-enabled solutions as well. right from the firmware to the application stack which is built on top of these IoT devices. And often that's not there. That's not there from the large device makers. It's not there from even the custom development that organizations do themselves. Second part of it is the skill. The right training, the right people to be actually doing this development and the testing. Because once you bring resource constrained items like IoTs into your development mix, you need a completely different kind of mindset to both develop, code, test. Right? I mean, we are now, if you're a cloud developer, you're completely used to abundance. Right? We don't think of resource constrained environments at all anymore. Right? However, that's a very, very different paradigm. And now if you are building the two together, sensing IoT devices at the edge enabled by cloud, on one you have abundance, one you don't. So how do you build a solution that works?
I think this is very interesting because it goes down to the basic of security. Right? Security is as weak as or as strong as your weakest link. Now, when you talk about IoT in supply chain completely, you look at a lot of vendors who collaborate to bring in a product. Now, for the source company, the security standard might be X. For a vendor, it might be X plus or X minus. And then it also can have a lot of, okay, I need to look at my module, and how do I look at my module? So can I get a remote access to the module to, fix the bugs or send an update to my module? These are kind of things which might seep in. And that, for me, is a bigger challenge to look at it, because now you're looking, so earlier it was one company, one tool, now you're multi-company and you're like bringing it together. So it's in true world, global village or global security, what you're talking about. That brings in a lot of challenges with the security standard. Now, if I am a service provider, I might be working for 10 different companies. So I might have my standard, but those 10 companies might have different standards. So am I complying to that? Who is accountable for that? Those are the challenges what I look at. I think this also brings to an interesting question, which I usually try and ask is, if something goes wrong, who's accountable? Say it's an auto-driven car, or at your house, like the HVAC thing happens. Is it, if the third party gets injured, is that the vendor? Is that the people who have made it? And how do you look at the legality? I think those are the strategies which you need to look at going forward to work on this.
Yeah, to add to what Sudarshan and Suha just said, the biggest issue what we have is the sheer number of people involved in, or the number of entities that are involved in putting up an IoT device together. And the biggest issue over here is how much of trust do we put onto them in terms of, are they getting their processes right? Are they doing the right things before they are supplying the components to me? I think that's one of the most crucial part that is missing. Like, for example, if I buy a device from a vendor A, he in turn sources the board from vendor B. Finally, when I get it in my hand, do I have a software bill of materials or a detailed component list as to what has gone in that board? If I don't have that, I'm completely tied up. And believe me, there are many such vendors who are very quick to put things together. I think, again, would go back to Suha's point over here, is the IoT industry and the supply chain industry, we actually play a lot on the price point. We don't have the luxury, every penny counts over there. So there would be a few vendors down the chain who might end up cutting up a few corners, and we would be ending up having those products in our board. But if we don't understand what is there on the devices, it's going to cause a big problem. Now, on what needs to be done, there are some procedural aspects or governance aspects that can be put in place. There are some technical aspects, controls that can be put in place. One would be trying to ensure that we have the right bill of materials from all the vendors who are downstream, and we should kind of enforce or try to push in third-party assessments. That way we can at least try to maintain some level of parity, or to ensure that they are at least there somewhere, we can have some level of trust on them.
Yep.
Take it?
Okay. Yeah, no, I just try to, bring a little bit different angle in a sense that, in this entire supply chain and IoT, whether it's a vendor or OEM, I mean, whosoever it is, basically, at the end of the day, I believe two things very strongly impacts. So the first thing is the attitude about whether it's an OEM, are you really thinking seriously about the security, or it's just a checkbox in your process? So probably, one really needs to think about it and develop a positive attitude towards security. Now I believe time is changing, and people are becoming more and more aware and taking these things into their processes. From vendor side, then the deployment, or maybe if it's a OEM, the deployment, how engineers are deploying it, because if you think there's nothing wrong with AES encryption, right? We all agree to that, but how it has been deployed, I think that makes a lot of difference. So yeah, wherever you are, whatever the role you are playing, I think these two things make a very huge difference.
Right. So my take is that there is a silver bullet for solving this problem. And it's not one, it's two things, blockchain and AI. Can anybody think why are these two technologies going to solve this problem? Yeah, there are two reasons for it. One is, I thought the panel is getting boring. Second is, I just wanted to use some tech jargons because we're taking a video. All right. Now, speaking of tech jargon, let's go a bit lower level. So, tell me, how does the security within the development life cycle look like, from a tech perspective? What are the real challenges within the software development? Kedar, do you want to start?
So, I think what's happening is that one good thing is that there's a lot of attention being given to security as far as firmware development is concerned and cloud-based development is concerned. But security along the supply chain almost becomes like an afterthought. I think the first thing is to getting sensitized to the fact that as you are building end devices, the supply chain should completely be untrusted. And it's up to you to say that, okay, this is my one point of trust within the supply chain. Everything before is untrusted and everything after is untrusted. And once you start looking at it like that, figure out what do you want to do at that place where you put your trust in. And I think a couple of things that almost always, table stakes always have to be there is ensuring trusted boot, where only secure firmware is executing on the devices. And that too, NIST approved security mechanisms, RSA 2048 or above, or ECDSA, with private keys locked in some safe somewhere, so that it's almost impossible for people to, replicate that firmware, run untrusted firmware on the devices. Second is device attestation, where, and this is something that you have to bake in because it becomes part of the product experience also, where you're saying, how does my phone application or my ecosystem validate that this is really the device that I made and not a fake device that somebody made in my name, right? And it's potentially, siphoning off data or doing other things. And then I think those two things, what essentially they ensure is that they let you build trust, because now you're looking at it from the point of view that I'm trying to solve it by saying everything is untrusted, and I ensure that these mechanisms sort of build the trust along the way. Obviously, there are other parts or other additional components that you'll have to supplement to this, but this becomes like the very much baseline that has to be considered.
Asim, I mean, it's just a funny thing that actually happened at one of the places where I was working. He just mentioned about 2048 bit encryption. Now, the reality is, we were handed a box which we had to secure it, and the decision, what configuration and all, we didn't know. We got it from the business, and when we got the box in our hand, we looked at the specs. We couldn't go ahead with a 64-bit, not even anything more than 64-bit. So that's the reality of the IoT world where we are living in. So again, coming back, it's all about money. It's all about dollars and pennies.
Yeah, but as I said, I think, I think one of the important parts that we did not consider is all of these things always require some unique programming on the devices, which also becomes a significant cost adder, because it's, manufacturing lines are much geared to building things which are like, the same thing gets burnt on all the devices and it gets shipped. For many of these things, you require certain unique certificates or secrets being programmed, which in itself adds to the cost. But I think thankfully today, if I look at, there are certainly, as you get to real fringes, things become tricky. But if I go back to my earlier analogy of a light bulb, for example, there's a software and hardware capability which should ensure that at least the NIST prescribed, basic crypto has to be available or beyond.
Yeah. I would say that if you're a procuring organization, we should go back to the good old virtue of specifications, right? And make sure that the vendor delivers to those specifications. I mean, we have stopped spending enough time in specifying requirements. So that's one. I'd say that if you're an organization who is building the products, then if you do it at an enterprise scale, it's not that difficult to build in some time for threat modeling, for example, specific to that device class, and testing. And I think it's a plug for Pi2 as well, that they have some excellent testing products for different classes of IoT devices. You use those, right? And it will not solve everything, but it will surely take care of all the low-hanging fruits.
Okay. Yeah. All right. So I just wanted to add, since Asim is really interested or talked at a lower level, right? I mean, if you consider any IoT device, right? It's a supply chain or wherever it is going to be. I mean, it's a part of like hardware and the software both, right? So at the hardware level, again, what level of vulnerabilities and stuffs are there, which could be inside, let's say, at the silicon level, or the developer has left something at the board layer, or if you go to the software side, whether your binary's got some vulnerabilities inside it, or if you go one layer up, which is like your network or a cloud connectivity. So, I mean, right across all the layers, I mean, it is really hard bounded. If you just lose one loophole at any of these, I believe, and again, unfortunately, each organization, not everybody can really have the expert in each individual domains, whatever these layers are. So ultimately, that's where people need to really look out and seek the help from the external vendors and what has been done outside best by the best talent.
Yeah, I think we are probably at a stage where we were in terms of software security in the 80s and 90s. Like, why do I need passwords in my internal network? So those kind of things. So we have had conversations with the companies where we talk to them and they say, "Oh, our devices are really secure and protected." So we ask how. Oh, we are using AES 256. Okay, and how do you manage the keys? What? How do you manage the keys? We store them in the firmware. Okay, where's your firmware? It's in our external flash. What? Oh, but why would somebody open the device? So yeah, and we've had multiple such conversations on different aspects. All right, I think we are running out of time. We've 5 minutes left, right? So let's start with your 2 cents on how the future looks like, and then we'll ask the audience to grill you.
So from a future perspective, I think zero trust. And again, I'm going to quote again Asim over here. It's very easy. He gave me the answer up ahead. So how much we can leverage AI to improve our predictive capabilities. I think these are some of my 2 cents on how we can bring a little bit more security or embed some more security into that layer.
Yeah.
Sorry to disappoint you, ladies and gentlemen. My take on the future is things will get much worse before it gets any better.
That means more business for us. Yeah.
That went dark quite quickly.
No, I think I don't look at gloom and doom. I think, as he says, if the future is going to be dark, then we have opportunities, and we are all together in there. I think the way I look at it is, yes, the world is going to be connected. We have everything at home. Now, there are questions on privacy which will improve. There will be, it's also always a cat and mouse chase, right? So sometimes we are ahead, sometimes they are ahead, but this will happen. My thought is, let's look at what are the loopholes, what we see, how we can have the process which is stringent, how we can have technologies which are good and can be implemented, or the technical jargons, whichever you want to throw, are good. I think there are 2 things to look at it. One is a prediction and see what can be secured. But second is also, in case something goes wrong, how can I stand up faster, and what is my learning so that I can plug it in immediately with an entire place. Now, I think Log4j was a very good example where people did not have a list of things where all this would be used and how to do it. Maybe that is one of the areas which will become even bigger if you have connected networks. So just food for thought.
I think awareness kills ignorance, and I think in a lot of cases that we discussed and some of the attack vectors that we also looked at, they got introduced because of certain ignorances or certain shortcuts that people took. But I think conferences like these, where we specifically debate about security and look at it from different ways, I think help makes product developers more aware about the security implications. And I do really hope that as more people start looking into it as an industry, we commoditize the cost of building this inbuilt security in all these devices much more easier for everyone to do and adopt.
Right. Well, from my side, I stay positive. And fully driven to make healthcare better. Okay. And obviously, I strongly believe server and clients are made for each other, and it's just that we need to connect them securely. And again, like the only thing which I always believe, one should really connect with their device first, well, before somebody else connect them outside. So that's what it is.
I think one more point which I would say, test of times, right? So we've all security, we all scared people, we all gave various kind of solutions at some point in time. Probably last 2-3 years have been testing time for most of us, especially from security side. When people were working from non-ODCs at an insecure place of their own home, probably people in one room, 3 different people from 3 different companies who can be competitors working together. But we did not see that kind of a breach everywhere. Human value went up. Support was good. IT security succeeded to a larger extent. I mean, I'm not saying we did the best, but it didn't go down the drains just like that. So we still have hopes. We're all together in it.
Yep. Agreed.
All right. Questions from the audience. Yeah. Please fire them. We have 2 chip manufacturers. We have healthcare manufacturers. We have industrial manufacturer and energy as well. So fire away.
Hi everyone, this is Anil from Carrier Corporation. I just have one question which is about the product which we are selling in US, okay, on the e-commerce website. It's hardly is $25 to $30. And we are making sure that we follow the basic security requirement. Now, if I add more security into it, the product will cost around $200. So should I add security into it or should I not add security into it?
Can I take that? I think it's an interesting question. The way I look at it is security is also demand-based. So if your $25 work addresses the thing what is there and it's not connecting beyond a point to which is going to be worse than that, then it's okay. But if I am looking to buy something which is going to secure my house and this data, this device can actually connect and be the loophole, I would be okay to spend $100 on top of it. So I think it's also about the applicability. It's not about just the price. So more money does not give you better quality. More money just makes you feel egoistic that I can buy better. That's my feel on it. It's need based.
Thank you for the informative panel. My name is Prashant. So I guess my question was for those of you who work with industrial control systems as well as medical devices. Quite a few of these devices like implants or even devices in the field in industrial control systems, oil pipelines and stuff, they are meant to last for several decades, right? Like I just moved into a building that's provided automation by Johnson Controls, and one thing that really scares me is that the building is meant to last for like at least 50 years before they tear it down. So, and you just talked about encryption, like the devices that we are deploying today are so resource constrained that you can't even support state-of-the-art encryption. So the circumstance does seem very dire. Like what really is the hope for devices that are meant to last 50 years then?
Yeah, do you want to answer this question or should I call security and ask him to go out?
Normally this is when we say, oh, let us take this offline. Give me a moment. But unfortunately, Mike is more intelligent than me. This is where even companies like us, we are also learning. If we look at how these devices are structured, they are meant to last for that long. But as an industry, one of the key issues is we are not able to keep pace with the changes in the PKI side. So am I going to assure you that tomorrow everything will be hunky-dory? No. That's the reason why we are over here, to understand, to look at what the industry is doing and slowly try to scale up. It's not going to happen overnight, but probably the next generation of products of, say, either from the medical side or building automation side, they will end up getting more and more secure. It's akin to what Asim was saying, the IT world where it was 15, 20 years back. That is where we are, and we also need our the Microsoft moment where Bill Gates decided after the 4.1 fiasco. So that's where we are, and as an industry, we all have to strive to bring all this up. As they say, the rising tide brings all the boats up. So that's the best answer I can give you at this point in time.
So I would say that if you are a consumer, you should expect to pay more. Right? I mean, every time let's take Alexa, right? I mean, most of the Alexa devices have a far-field microphone which is backed by a security chip. I mean, but you pay a certain amount of money, $30, $40 to $100 depending on the device. So that can support that cost structure. You can also buy these kind of speakers from very, very cheap sources, right? And obviously there is some corner that's going to be cut. So as a consumer, you should expect to pay more. As a corporate, again, I think it boils down to specifications.
I think one pleasing thing to note here is that at least for us, we keep hearing questions from customers where they're looking at crypto agility, which talks about how effectively can software on your chips catch up if there are enhancements or upgrades to crypto protocols so that even if the product is deployed in the field, it can be subsequently upgraded to use higher versions of the protocol. So that's definitely a great trend. The other threshold really is also the PQC, post-quantum cryptography. And that is, which goes back to your question also, because how things change before and after that is something worth looking at.
Yes, and one of the things I wonder is, all right, last question. That will be the last question after me.
No, we'll put trouble more on them. So the gentleman and on stage, like I taken actually notes. It was very interesting. We actually skipped the most interesting part of the segment, which was that who are all the threat actors. So if you see, can you hear us? Yeah. So if you start the way of the whole evolution process, we noticed a lot of great innovators are the movie directors. The Fast and Furious movie, shown in one of the movie, they show a submarine is been remotely controlled. At that time when I was watching, I was thinking, yaar, ye to pagal ho gaya, kabhi ho nahi sakta. Now people are talking about UAVs, that is underwater drones are evolved and that is remotely controlled. A drone is nothing but a small submarine. I can go and then take a hit. If I could compromise and then penetrate into that system, the remote control system. And is it only in defense where, like, no, if you say in 2018, if I'm not wrong, there is a think tank which is called Basics. They did a research on the Trident missiles which are put into a submarine, was remotely controlled by hackers. I don't want to name the country. So they could compromise and then they were initiated the sequence, but you need to put a physical key to fire. That was the only control which saved the Trident missiles not to be fired from the submarine. Right? So it was so complicated. But now it is easy. What was the malware that time? That malware was nothing but actually WannaCry compromised. So from there, now are we only looking at defense? No. Now if you see the CCTVs, I can't get into Asim's house and then see what's happening. But Asim has a CCTV that is connected to the CCTV network. I just need to sit outside and then compromise. So threat actor could be anybody. It's not only defense. The panel is, let's say, NXT system. Sue was telling, I want to know what is NXT system next planning. So I can see that he is wearing a red, maybe Apple Watch. So if I know how to get into, I can hear him. I know which room to room he is going to shift. So this has opened up interesting concept of hacking. One of young kid today afternoon, he met me. He was talking. He's like, "Aap hire kar rahe ho na in your company?" So it's like, how do you know? I overheard you. Now, people don't need to overhear you. All they need to do is they need to get into the system where we all are connected, too smart. We are losing smartness. So being said all this thing, my question is, there are so many things. Are we looking at it? I'm a baby, I'm asking you. Are we doing, we are looking at IT SOC. Do we have IoT SOC? Have we IoT SOC? Like OT SOC. Do we have OT SOC? If we have OT SOC, have we actually identified the IOCs? Do we have threat monitoring where threat hunting? Are we doing it? Are we rolling up sleeves, putting everybody together and then say, okay, we have identified these many threats, like Payatu is doing great job. So have we put it all together, sharing it between the organizations? Because I believe there is an organization called NCIIPC, which is formed. So is it being shared? CERT panel was there. They were talking about IT. Are we doing anything on IoT? Because you guys have actually really scared us.
So,
solution bhi bolna chahiye.
So let me try and tell you. You had all the answers. I don't know if you asked a question or gave the answer as well. But but the thing is, there are a lot of organizations who have OT and IT monitoring centers, and they are converging together. And now what you see is not only a SOC expert, but an OT expert also sits in that monitoring room, and then they control it. This line will merge at some point in time, and that is where the industry is moving. Is there a consortium of industry which actually talks about it? There are many, depending on the verticals of the industries or cross industries, and these are also very good areas where these kind of conversations happen. But yes, is everything private? So my take, I know we are recording, but my take is privacy is a myth. And that's a reality. You were talking about the watch. You know that Garmin was once actually accidentally shared the location of all the US military folks because they were doing a drill somewhere. Sorry, my bad. So yeah, so these are reality. But yes, as Anand said, right, we are learning also. So it is a cat and mouse chase. Someday we will be better, someday they will be better. But this is going to evolve.
Yeah, and your question, your answer, both are to the point, but there is a lot more nuance to it. So companies are doing that. Many of us are doing it, but it's not just that. For example, IoTs are proliferating, so they will soon be 3x, 4x the number of your regular assets. Your SOC may notice something, your IoT SOC, but who the hell owns it? Where the hell is it located? Right? Just knowing an IP address is not enough. So you have to look at importing all your IoT data into your CMDB probably. Keep your owner's data updated, location data updated. It's a hell lot of work. And after that, even if you detect all of it, if it's an unupdatable, again, one of those $5 things, right? I mean, you have to, still at the end of the day, you have to physically send somebody to yank it off the network, right? I mean, so it's complicated. I think that's the summary.
All right. Time up. We're already 10 minutes past. We're 3:40, and I think people want to go for break. So we'll close here. You can come and ask the question after we close. All right. So some points from today's panel discussion. We need good skill set, specifically around IoT and embedded. We need to have some kind of a collaboration with third-party vendors on standards. We need to look at responsibility chain for when there are attacks or incidents. We need to build trust from grounds up, and we need basic crypto. All right. With that, thank you so much for accepting to come for this panel, and thank you so much, guys. Thank you.
Thanks everyone.
Thanks, everyone.
Thanks, everyone.